Okay, the next topic is adjoint of a matrix. Mhm. Two people have not joined. No? Vishnu Shri and Astuti. Okay. So to begin with, adjoint and inverse of a matrix. First, we have a definition of singular matrix. A square matrix is called singular if its determinant is 0. Otherwise, it is called as a non-singular matrix. So determinant A is equal to 0 implies A is a singular matrix. Okay, there's a definition of singular. What is this? Is a term that is used. This condition, singularity condition, is very, very important in finding the roots of the equations when we use matrix methods. So next definition is that of adjoint. So adjoint is defined as the transpose of the matrix formed by replacing the transpose of the matrix formed by replacing the elements of a square matrix A by its elements of the square matrix by their corresponding cofactors. By their corresponding cofactors. The transpose of the matrix formed by replacing the elements of a square matrix A by the corresponding cofactors is called as the adjoint of A. Okay. So let A be equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, cofactors of A is replacing A1 by its cofactor, B1 by its cofactor, C1 by its cofactor. All right. These are cofactors. What are cofactors? Eliminate the row and column and take the determinant of the remaining submatrix multiplied by -1 to the power I plus j. That is the cofactor. Okay. So this is a cofactor matrix. Adjoint matrix, adjoint of A is transpose of the cofactor matrix. So this is A1, B1, C1, A2, B2, C2, A3, B3, C3. All right. Now a property, very important property. Very important property. Note. What is A into adjoint A? A1, B1, C1, A2, B2, C2, A3, B3, C3 multiplied by adjoint is A1, B1, C1 is column wise. Now just observe what you get. A1 multiplied by capital A1 plus B1 multiplied by capital B1 plus C1 multiplied by capital C1. What is it? Equal to elements multiplied by their own cofactors and summed up. What does it give you? Anyone? Anyone? You have attended? Anybody can guess what is this value? A1 capital A1 plus B1 capital B1 plus C1 capital C1. What is its value equal to?
Determinant.
Very good. Very good. This is determinant of A. That's how we define determinants, isn't it? What was our basic definition of determinant? Minus, yeah, this is the definition. Elements of any row or any column multiplied by the cofactors and added. That gives you determinant. So this is determinant. Okay. Next. Then A1, A2, B1, B2, C1, C2 summed up. A1, A2 plus B1, B2 plus C1, C2. This will give you what? What will this give you? Cofactor, the elements of the first row multiplied by the cofactors of the second row. A2, B2, C2 are cofactors of second row. So elements of a row multiplied by cofactors of another row. 0. Then A1, B1, C1 multiplied with A3, B3, C3. A1, A3 plus B1, B3 plus C1, C3. What will that be? 0. Very important. Because elements of row 1 multiplied by cofactors of row 3. Again, it will be 0. Next, elements of row 2 multiplied by cofactors of row 1. 0. Elements of row 2 multiplied by its own cofactors and added. You get determinant A. Then elements of row 2 multiplied by cofactors of row 3. 0. Okay. Then next, elements of row 3 multiplied by cofactors of row 1. 0. Elements of row 3 multiplied by cofactors of row 2. 0. Elements of row 3 multiplied by cofactors of row 3. Determinant F. So I get, if I pull out, because it's a matrix, if I pull out the determinant, it comes out of the entire matrix. So from here, we proven very important results. A into adjoint A is adjoint A into A is determinant of A times I. Very, very important result. Matrix multiplication is commutative. That's why we can do this. A into adjoint A is equal to adjoint A into A. As long as they're square matrices. Always not necessarily true, but this is true. A into adjoint A is adjoint A into A. Next. So from this result, I'll do something. You just see this. Note 2. Now we have this relation. A into adjoint A is adjoint A into A is equal to determinant of A into I. Determinant of A into I. Now, dividing by determinant of A throughout. So 1 by determinant of A into adjoint A, 1 by determinant of A, adjoint A times A equal to I.
Sir, it's 1 by determinant of A.
So we get A times 1 by determinant of A to adjoint of A, 1 by determinant of A into adjoint of A times A equal to I. All right. So now you see this is a matrix. So now comes the definition of inverse. So now I'll write this as A into B is equal to B into A is equal to I. So so now inverse of a matrix. So inverse of a square matrix. Inverse of a square matrix. Now let A be a square matrix that is non-singular. If there exists another matrix B, another square matrix B, such that AB is equal to BA is equal to I, then B is said to be B is said to be the inverse of A and is denoted as B is equal to A inverse. All right. Now, what is that value of B? Now, from the previous result, we get A into adjoint A by determinant of A is equal to adjoint A by determinant A times A is equal to I. A into adjoint A by determinant A is equal to adjoint A by determinant A times A is equal to I. So compare with A times B is equal to B times A is equal to I. Thus, B, which is equal to A inverse, is equal to adjoint of A by determinant of A. Adjoint of A by determinant of A. Okay. So very, very important result. A inverse is adjoint A by determinant of A. Okay. Now some properties of inverse. Properties of inverse. A inverse, the whole inverse, is equal to A. Then A transpose whole inverse is A inverse times transpose.
Sir,
Yes?
can you please scroll up a little?
This one?
Yes, sir.
Yeah.
Sir, done.
Okay. So if we invert an inverse, then we get back the original matrix. Okay. And so that's what it is. A inverse whole inverse is A. And A transpose whole inverse is A inverse whole transpose. There's another one. And last one, AB whole inverse is equal to B inverse times A inverse. AB whole inverse is B inverse times A inverse. So these are some properties. Just like AB whole transpose is B transpose A transpose, like that AB whole inverse is B inverse A inverse. So these are some results. Let us do this simple 2 by 2 matrix. Problems on adjoint and inverse. Find the adjoint and inverse of a matrix one, 2, 3, minus 5. 1, 2, 3, minus 5. Find the adjoint and inverse of this matrix. Okay, I'll give you time. Solve. Yes, anybody? What do you do first? So let us say A is this matrix. First write its cofactors. Cofactors of A. 1 replaced by its cofactor. Remove row, remove column. You have minus 5. So minus 5. Then 2 multiplied by its cofactor. What is its, sorry, 2's cofactor is remove first row, second column, and determinant of the rest, that is 3 with a minus sign. Then cofactor of 3 is 2 with a minus sign. And then cofactor of minus 5 is 1, that is with plus sign. All right. So this is cofactor. Now, what is adjoint? Adjoint is transpose of this matrix. Transpose of the cofactor matrix. Okay, this is adjoint. Generally what happens is adjoint means, no, we'll write inverse and then I'll tell you what happens. How to remember this.
Sir,
Yes.
is the inverse 0
Which one?
for this question itself?
What is 0?
The inverse.
Inverse is 0, sir.
No. No.
Sir, but the determinant of the matrix is 0, right?
How? 5 minus 10, 5 minus 6 is 0. No, right? So determinant of matrix A is determinant of 1, 2, 3 minus 5. Determinant is minus 5 minus 3 into 2. Minus 6 minus 5 is minus 11. So this is determinant. Now what is inverse of a matrix? A inverse is adjoint A by determinant of A. So adjoint matrix is 5 minus 5, 2, 3 minus 1. And determinant is minus 11. So A inverse is now 5 by 11 minus 2 by 11, 3 by 11 and plus 1 by 11.
Sir, it's plus 2 by 11 also.
With minus is there, no? Minus 11 is there in the denominator. Okay. So this is the A inverse, adjoint A by determinant of A. So for a 2 by 2 matrix, okay, a general formula, if A is A, B, C, D, then
Sir,
uh,
adjoint A is minus 5 minus 2, right? Why did you write 2 only? Yes. Minus 5 minus 2 minus 3 and 1.
sorry,
Like in the
sorry, yeah,
formula
I overlooked, sorry. This is 1. So I'll get plus, 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 minus. Okay, this is right. Okay, do this. If A is this, you know, somebody is knocking the door, I'll just open the door and come. In the meanwhile, you just solve this. Yes, anyone?
Sir, is the answer D minus B minus C A upon DA minus BC?
Yes. See, determinant of A is AD minus BC. So 1 by AD minus BC. And the transpose of the cofactor. Cofactor of A is D. Cofactor of D is A. Cofactor of B is minus C. And cofactor of C is minus B. But when you transpose, minus B comes here, minus C comes here. Okay. So A and D gets exchanged, DA. And this B and C are replaced by minus B and minus C. So this is the adjoint matrix of A. All right. So A inverse is 1 by AD minus BC times D minus B minus CA. So this is standard form to remember for 2 by 2 matrices. Inverse you can very easily find out. All right. All right, next we will do one more. Now this was 2 by 2, now we'll go for 3 by 3. If A is equal to 1 minus 2 3 0 minus 1 4 minus 2 2 1, then find A inverse. Then find A inverse. Let's do this. Solution. What do you do first? Write its cofactors and then find the determinant. Okay. Cofactors of A and then write adjoint. Now what is cofactor of 1? It is determinant of this submatrix minus 1, minus 1, 4, 2, 1. So minus 1 into 1 is minus 1, minus 8. So minus 9. Cofactor. Cofactor of minus 2. The second term, remove the first row and the second column. Then you are left with 0, 4, minus 2, 1. 0, 4, minus 2, 1. So 0 into 1, 0. Minus of minus 2 into 4. That is minus 8. 0 minus of minus 8. So that is plus 8. This cofactor, now you remember this. 0 minus of minus 8 is plus 8. but the second term is associated with a minus sign. So you get minus. The third term is associated with a plus sign, third element, plus sign. So let us see this. Remove the first row, first row, last column. 0 minus of minus 2 into minus 1. So minus 2. 0 minus 2 associated with a plus sign. Then cofactors of 0. Cofactors of 0, remove the first column, second row. Then you are left with minus 2, 3, 2, 1. Minus 2 into 1 is minus 2, minus 6. So minus 2 into 3. So minus 6. So minus 8. Minus 8, then associated with a minus sign, you get plus 8. Next, cofactor of minus 1. Remove the second row, second column. Then take the determinant. 1 into 1 is 1. Minus of minus 6. So 1
Sir,
minus of minus 6 is 7. Yeah.
sir, the next number is going to be 2, minus 5, minus 4, and 1.
Let us see. Minus 1. This is minus 1 minus 0. So 1. This will be associated with plus sign. This will be associated with a minus sign. So it is minus 1 multiplied by minus. So you will get 1. Then next, for minus 2, the cofactors will be minus 8 plus 3. Minus 8 plus 3. So it will be minus 5 associated with a positive sign. So minus 5. Next, this one. Yeah.
I think the previous element where you wrote 1, I think it has to be 2, right? Minus 2.
How?
2 minus of minus 2 into 2 is 4, right? So 2 minus 4 is minus 2.
Oh, I'm sorry. Sorry. This element, right? I have to remove this second row and the third column. Then I'll get 2 minus of 4, that is minus 2 with a minus 2 minus 4. So I get minus 2 with a minus sign, I get plus 2. Right, you're right. Then the last one I get minus 1 minus 0. So I get minus 1. This is cofactor. Then adjoint of A. Adjoint of A is transpose of this. Minus 9, minus 8, minus 2, 8, 7, 2, minus 5, minus 4, minus 1.
Sir?
Hmm.
Sir, it is supposed to be 4, right? For cofactor instead of minus 4.
No, again it's the third row and second element, right? That's why we need to add
Third row, second element, it is 4. Yeah, 4 minus 0 is 4 associated with a minus sign. So it is minus 4. Got it, Prisha?
Oh, okay, sir. So you directly took it. Okay.
Yeah, I'm multiplying each one with, if you have a doubt, first step you just write minus. Second step you write cofactors.
Yes, I thought you were finding the minor. My bad.
Then I'm directly writing the cofactor. Now what is determinant? Now determinant of A. You take any of the cofactors, any of the elements, multiply it with cofactors. So 1 into minus 9 plus minus 2 into minus 8 plus 3 into minus 2. So I get minus 9 plus 16 minus 6. So I get 1. 10 minus 9, 1. I can choose the second row multiplied by the cofactors of second row. 0 into 8, 0. Minus 1 into 7, minus 7. Plus 4 into 2, 8. So minus 7 plus 8 is 1. Third row multiplied by its own cofactors. Minus 2 minus 5, 10. Plus 2 into minus 4, that is minus 8. 1 into minus 1, minus 1. So I have 10 minus 8 minus 1. So again 1. So anything you can take. So this is determinant. Now inverse is A inverse is adjoint A by determinant A. Adjoint A by determinant of A. So 1 by 1 times this one. Minus 9, 8, minus 5, minus 8, 7, minus 4, minus 2, 2, minus 1. So this is how you evaluate a third order, square matrix of a third order. Inverse of a square matrix of a third order. All right. If you have copied, I'll move further. Yes, can I go further? So for a diagonal matrix, if A not equal to 0, B not equal to 0, C not equal to 0, then find the inverse of A 0, 0, 0, B 0, 0, 0, C.
Sir, null matrix.
Inverse cannot be null. Inverse cannot be null matrix.
Okay, sir.
So let us find this quickly. A is A 0, 0, 0, B 0, 0, 0, C. Let us find the minors.
Sir, A will be replaced with BC, B will be replaced with.
Let us do that. A is replaced by BC. 0 is replaced by 0. Yeah. 0, you remove row and column. You have 0 into C minus 0 into 0. This 0 is replaced by, determinant of 0, B 0, 0. So again 0. Then this 0 is replaced by 0. B is replaced by AC. This 0 is replaced by 0. This 0 is replaced by 0 again. This 0 is replaced by 0 again. This C is replaced by AB. This is minor. Cofactor, you have to multiply with plus, minus, plus, minus, plus, minus, plus, minus, plus. So these diagonal terms have plus in them. So these are associated with the plus sign, so no problem. All right, this cofactor. What is determinant of A? Elements multiplied by their cofactors.
ABC.
Good. What is adjoint of A? Same, BC, AC, AB, 0, 0, 0, 0, 0, 0. Okay. What is A inverse? Adjoint of A by determinant of A.
1 by A and 1 by B and 1 by C.
Yes, correct. So when you divide, you get 1 by A, 0, 0. Then 0, 1 by B, 0, 0, 0, 1 by C. So what is an important lesson? When you multiply, when there is a diagonal matrix, inverse of a diagonal matrix is another diagonal matrix with elements as the reciprocal of the original elements. Only the diagonal elements as the reciprocal of the original diagonal elements. As long as A, B, C are non-zero, you can get this. Otherwise, you cannot. See, for inverse to exist, very important, condition for inverse to exist is that A should be non-singular. All right. Otherwise, inverse will not exist. All right. Note, very, very important. Adjoint A by det A is A inverse. This implies for A inverse to exist, A must be a non-singular matrix. It must be a non-singular matrix. Otherwise, it cannot. Hmm. Hmm. Next, last question for today. If A is 0, 1, 1, 1, 0, 1, 1, 1, 0, and B is half of B plus C, C minus B, B minus C, C minus A, C plus A minus C, and then B minus A minus B, and A plus B. Then show that A, B, A, B, A inverse is a diagonal matrix. Okay. So this is A. So we'll find minor and cofactors of A. So let's find minor. Replace elements with the minors. 0 minus 1. 0 minus 1. 1 minus 0. And next. 0 minus 1. 0 minus 1. Then 0 minus 1. Then for this one, 1 minus 0. 0 minus 1. 0 minus 1. This is a minor. Cofactor. So this needs to be multiplied with plus, minus, plus, minus, plus, minus, plus, minus, plus. So cofactor. So plus sign with a minus sign, plus sign, minus sign, plus sign, minus sign, plus sign, minus sign, plus sign. Okay. So I've multiplied 1, 2, 3, 4 by negative 1. So 1, 1, 1, 1. There we go. All others remain same. Now these are cofactors. Now what is the determinant? Determinant of A is 0 multiplied with minus 1 plus 1 multiplied with 1 plus 1 multiplied with 1 equal to 2. So adjoint A, because of the symmetry, adjoint A and cofactor A are symmetrically placed. So adjoint A is same as cofactor A. A inverse is adjoint of A by determinant of A. Determinant of A is 2, so I get half of all right. This is A inverse. Now what do we have to show? A, B, and A inverse. Okay, time is up for today. We'll continue this in the next class. You can solve from here. We'll continue in the next class. All right, so A inverse, A multiplied by B, and then this multiplied with A inverse. We have to find that it's a diagonal matrix. We'll have to show that. All right, we'll stop for today. Any questions?